Maritime Made on Eastlink TV is presented in partnership with Nova Scotia Business Inc., novascotiabusiness.com.
In beautiful Mahone Bay, Nova Scotia, you'll find RPS Composites, making some of the strongest, most durable, lightweight industrial pipe in North America. If you need pipe for difficult conditions, look no further. At RPS Composites, each order for fiberglass reinforced pipe is unique. A team of engineers, designers, and draftspeople work together to create a custom solution for each project. Some customers may need fiberglass reinforced pipe to safely handle corrosive fluids, while another customer may need a unique design to handle large volumes. The engineering department is involved in selecting materials suitable for the challenge the pipe will face. The drafting department creates three-dimensional drawings for production. Once these are verified, they're ready for production. Fiberglass reinforced pipes are made on a mandrel or mold, and many different diameters can be made.
To begin, this 18-inch mandrel is wrapped in corrugated cardboard. Then, a layer of mylar is rolled on top. The mylar acts like a release film and ensures the resin doesn't stick to the cardboard. The worker applies the mylar tightly and evenly. As the mandrel slowly rotates, clear resin is poured over the mylar layer. Then a layer of fabric called Nexus Veil is applied, slightly overlapping each layer. This layup stage builds up the interior of the pipe. The work is done by hand and inspected for consistency. Several more layers of material and resin will be added, then cured. This pipe is ready for the middle layer and will be built up with fiberglass roving. The roving is threaded into the roving carriage. The roving is weighted down so it runs through the sticky resin before being applied to the pipe. The carriage moves up and down along the pipe, applying the roving and building up the pipe until a specific thickness for the structural wall is achieved.
Each strand of roving contains 4,000 glass filaments. The comb on the carriage keeps the roving separate from each other. The delivery ring compacts the rovings into a band. The machine is computer controlled to apply this band at a specific angle. Workers remove excess resin with a scraper. This excess resin will be reused. When the pipe has been built up, the rovings are cut and material is added to keep the roving ends secured. Workers roll the pipe with a felt roller to smooth it out and visually inspect the surface. A layer of color is applied next. It's mixed with a hardener and a UV protector. The hardener starts the curing process right away. This is quick curing resin and has no need for an autoclave or heating oven. Heat lamps are moved into place to help the curing process. The temperature and length of time to cure depends on the humidity and temperature in the production facility.
The pipe turns continuously as it cures to ensure the resin cures at a consistent rate and thickness. Once cured, the pipe is sanded. Then another layer of gray will be added. Once a pipe is complete, it is moved with lifting hoists to the extraction wagon. Steel cables are attached to each mandrel. A winch with 25,000 pounds of force pulls the pipes off the mandrels. Then the worker removes the mylar release film from inside the pipe. The pipes are then moved to the cutting area, where the rough ends of each pipe are trimmed with a saw one end at a time, then rolled on to the next area. The worker then hoists one end of the pipe into the belling machine, where the end of the pipe will be flared. The pipe is turned by applying pressure to the turning wheel. This will create a bell and spigot pipe. One end is flared and the other end will be tapered. Every pipe is quality tested at RPS Composites. Last year, roughly 20,000 individual items were quality checked on site. The quality assurance technician checks the outside diameter of the pipe, as well as a visual inspection inside, looking for any possible flaws or debris. Each pipe has a tracking number, which follows the pipe through the process. Pipes must be built within millimeters of specifications. The specifications are checked against the tracking number.
Resin for each order is prepared on site in the resin room. Internal orders are placed and technicians weigh, measure, and mix the ingredients for each order. Depending upon the specifications for a particular pipe, resins have different thicknesses and blends. In the mat room, materials for the pipe fittings are cut and prepared based on specifications. Pipe fittings like elbows, flanges, T's, and reducers are made using molds. The composite technician checks the order and begins to work. Wax is applied to the warm mold so the part will come off the mold more easily after it's finished. Hardener is added to the resin to quicken the curing time and is mixed in. Resin is liberally applied to the mold.
Nexus Veil is the first layer of material applied to the mold to start to build up the part, in this case, an elbow. Resin is applied to ensure the Nexus layer is thoroughly soaked. The resin is hand-rolled to remove any air bubbles which would weaken the fitting. The next layer of fiberglass is soaked in resin and applied. Layers of material are added in the same way until the part is fully built up. It cures while turning continuously under a heat lamp for an even finish. At RPS Composites, products are shipped in specialized crates to industrial locations around the world.